Hello and welcome to the second part of this tutorial. Today is going to be quite awesome. We're going to just set up the map menu right here. So if I click on the first level, we're going to load in the first level, and then we have a player, a spaceship that we can just move around freely on the screen. The spaceship is going to tilt sideways when we move to the left or to the right, and we cannot move out of the screen right here. And this whole thing is already going to work on your mobile phone. So stay tuned, like the video, subscribe, and the link to the whole playlist is going to be in the description down below. So let's get started. And as always, you can get this scene and the end scene from the links down below. So today we're going to be implementing the joystick, as you saw, and the spaceship. And what we need a joystick for that, which means we want to go to the asset store, just type in joystick, and then select the free button right here, the free asset. And then what you want to do, just go to the green here for Fenerax Studios and just click a quick look and then import like this. Leave everything on and just click import. Once it is done importing, you should have a joystick pack folder in the assets. And if you don't have the asset store window, just go to Windows and then the asset store right here, or curl 9. I will link this asset in the links down below, and also if you download the start scene, it will already have the joystick pack in it. So let's start by making the level buttons work. So go to our scenes folder and then go to right click, create, and then go to a new scene and call the scene, let's say level 1. Double click to open it up and a new scene will open, and then go to your skyboxes folder and the skybox 2.-2 and then just drag and drop this one in here. And let's play around with it a little bit and just make it look like, sure, this looks decent like this. And now let's create a canvas in here in this new game scene, the level 1, and go to UI and then the canvas like there. And as always, go to your canvas scaler and scale your screen size and make this the 1280 by 720, the HD resolution. Right click on our canvas, go to UI and create a new button. And this is going to be the exit level button. So let's rename this to exit level button. Double click to focus on the button and then select a new sprite. And let's select the sprite that we have for everything. So go to the button right here and then go to the, the transition and then sprite swap. And then already the pressed button, we want to do the sprite here for this. Okay, that's good. And go to the text again and just call this exit. And go to the font and let's make it as always the Roboto bold, and the color is going to be white, and then let's add a shadow like that, and let's go to like 2 and -2 and resize the button, and let's make it like 100 by 60 or 130 by 60. And now select the rect transform, shift click and go to the top right, and then the position, let's make something like 100 and 100. And let's make this negative, and let's make this also negative. Let's put in something like -75 and -75. And next up, go to our scripts folder and create a new C# script. Let's call this the in-game manager. Open it up in Visual Studio. And what we want to do in here, just make a public function for the button, a public void on exit button clicked, and just go to the scene manager. But for that we need to be using Unity engine.scene management. Now we can access the scene, so scene manager.load scene, and then type in what did we call the scene. So go to your scene folder, we called it the menu scene, so just load the menu scene. Now we still need to be able to load the first level, so go to the menu scene, save all changes. Then go to your scripts folder and then the menu manager. You also want to be using the Unity engine.scene management. Now we can load the first level. So if we go down here for in the function where we actually have the on level select, here after the debug print we want to be just loading the scene manager.load scene and just call the level 1 for now. Now we need to add our scenes to the build settings, so go to the scenes folder and go to the file and build settings and drag and drop these two scenes in here and make the menu scene the scene with the index 0. We forgot some stuff in the level 1 scene, so just go to the level 1 scene by double clicking on it, right click on in the hierarchy, create an empty game object and call this the in-game manager, go to the scripts folder and drag and drop the in-game manager on here, and now go to the canvas and the exit button. Since now it doesn't do anything, click the plus sign, drag and drop the in-game manager in here, and then select the in-game manager and the only function we have on exit button clicked. So now go to the main menu and let's try it out. We should be able to just go in between scenes now. So if I hit the play button, now if I go to the play menu, the map 1 menu, and then select the level 1 button, we should be able to load the level 1 scene. And now if I click the exit button right here, we should be able to go back to our menu scene right there. Awesome. Let's go to the level 1 scene and get our spaceship working. So go to the level 1 scene and then go to the assets folder, and where do we have it? The start sparrow folder, prefabs, and let's just drag and drop the star sparrow number 1 in here, just like that. Double click to focus on it, and if we go to the game view, we already see our spaceship in here. So what we want to do, let's try to move it forward a little bit. So let's just try something like this. Okay, this looks good. Let's put it on 5. And let's work around with the main camera so it looks better. So go to the main camera, double click on it, and just let's put our main camera up like this. Okay, this looks good. Let's do something like 3.8. This looks awesome. And let's also rotate the camera so that we have a top-down-ish view on it. So let's try something like, okay, this looks good. Let's put 8.1. This looks pretty awesome. We just have a model in our scene, but let's put a joystick on here. So go to the assets and then the joystick pack and prefabs, and let's use a fixed joystick and drag it under the canvas right here. Now if I hit the play button, we can already move around with the joystick. And this will also work on the mobile phone. Go to the fixed joystick and let's position it somewhere else. Go for something like 160 and then 160 on this too. Awesome. And then right click on the rect transform of the joystick and copy component. And once we get out of the game mode, just right click on the rect transform and paste component values. Now we just move it down as we want to. Awesome. Now let's actually make our spaceship move. So go to the scene view, undo the 2D mode right here. Now we see our spaceship in 3D, and go to the spaceship and add a rigid body right here. And what we want to do, if you go to the game, back to the game view, we want to constrain. So open up the constraints, and we don't want to use gravity since our spaceship would just fall down. That's not what we want. We want to actually just swing around with it. So what do we want to use? We want to use the y-axis, so the position, that's good. We want to use the x-axis, move sideways. We do not want to use this for now. Okay, so now just go to the rigid body and disable the freeze position Z. Now the rotation, what do we want to use for the rotation? We do not need this rotation for now, so just freeze the X rotation. And we also don't need the Y rotation. We don't want this, so just freeze the Y rotation. We do want to do this basically, and you'll see why. So if I move this to like, let's say 11, then move the X position. So I want this effect right here. So if we move to the right, I want our spaceship to rotate slightly. So that's good. We keep that, and let's make a script to actually be able to move it. So go to our scripts folder right here, and then create a new C# script, and let's call this player controller. Open it up in Visual Studio. So what do we want in the player controller? First off, we need a public reference to our joystick. So just go public joystick and call this the input. This is going to be the input, because if we go back to Unity and click on our fixed joystick, we can see a fixed joystick script right here. So if I go to the joystick pack and the scripts folder of the joystick and the joysticks and open up the fixed joystick that we are using, I just can see that we are inheriting from the joystick. And right here, if I double click on the joystick and hit F12 in Visual Studio, it opens up the base joystick class. So we inherit from the joystick, so we can just use the joystick in our player controller right here as a reference. So that's good. We have an input that we can use, and we are just going to assign it in the inspector. Now we also want a public float. Let's call it smooth speed, and let's set that equal to 10. Now we also want a reference to a rigid body, private rigid body. We are going to set that up in the start function. Let's call this RB. Let's go to the start function and just set RB equal to get component and make that the rigid body. Like this. Awesome. Now let's make a function for moving our player. Let's make a private void and call this move player. This function is just simply going to get the inputs from the joystick right here and assign it to the rigid body. Just make a float and let's call this the horizontal movement. and set it equal to the input, that's the joystick script, and the horizontal right here. And then make a float, a vertical movement, and set that equal to the input dot vertical, like this. Awesome. Now we also need a vector 3, so we can actually move our rigid body. So make a vector 3 and call this the movement vector. Set that equal to a new vector 3. And what we want to do? We want the horizontal movement for the x. Then we want the vertical movement for the y. And we don't want to move on the x-axis. Right here, the 0f like I showed before. And now go to the rigid body, which is the RB, and then velocity. And set that equal to the movement vector right here times the movement speed, since this is just going to be a float in between 0 and 1, or a vector 3 with floats between 0 and 1, and that would not be too fast. Right here, and just in the update, call the move player function. And now we already should be able to move with our player once we assign the references that we need. So go to the scripts folder and then drag and drop the player controller on the star sparrow script right here. Double click it and then just go to the input, and we need to drag the fixed joystick into our input. Now if we start the game and then just drag the joystick around, we can already move our spaceship. That's pretty awesome. But there's one error with it. Now if I just go upwards, I can move our spaceship on and on and on just all the time and endlessly. We don't have any constraints. So let's add some basic constraints. How are we going to set up the boundaries for this game object? So there's a couple of functions in Unity which are going to help us to do that. In this scene view, we have a main camera which we're using to display our game object right here, this game object. And we can actually calculate the distance from the camera to the game object. Right here, the game object has a center, and we can calculate the distance from the camera to the game object that we're using as our player. And then actually set the max y, max x, and so on and so forth for the game object on the world view right here, in the world system right here. So if I drag this out, this is about going to be the max, the min x right here. So it can't go further. And this is about going to be the max x right here. So it's just going to be the same, just positive right there, which is going to help us quite a lot. And the same thing goes for the y and the negative y. So let's try and do that in the script. Let's open up the player controller and let's make a couple of variables. A private float, and we need a couple of floats. Let's call this min x, the maximum x, then the min y, and the max y right here. That's what we need, and that's what we want to set up. So let's make a function for that. Let's call this the private void set up boundaries. Like I said, we want to get the camera distance first. So let's make a float, a cam distance. And let's set it equal to the vector 3.distance. And what we want the distance is just the transform.position, the distance from this game object, the spaceship. And then we want the camera.main.transform.position. Just get the main camera and its position. And this is a vector 3. Now, since we have the position, we can use a couple of Unity functions. Let's make a vector 2 for the bottom corners and set that equal to the camera.main. And this is a Unity function, the viewport to world point. Viewport to world point right here. And we want to put in a vector 3. So just make a vector 3, new vector 3, and put in 0 float, which is just the bottom right here, 0 float again for the x and y. And the z is going to be the camera distance. So this is how we get the bottom corners. And now if we copy this and just rename it to top corners, we can get them with the same function, just if we pass in a 1 and 1 vector and the camera distance again. And so let's assign those. The min x is just going to be equal to the bottom corners dot x. The max x is going to be equal to the top corner dot x again, and the minimum y is going to be equal to the bottom corners dot y, and the maximum y is going to be equal to the top corners dot y, just like that. So now we actually have to call this function in the start function so that we set it up right away. Now we have these values with the min and max y and x values. Let's work with those. So let's make a function in here in the update function. So after we move the player right here, we are moving the player, we are going to call a new function. Let's make a new function. Let's make a new private void, and let's call this the calculate boundaries function. what we want to do in here, we just want to get the current position vector 3 current position is going to be equal to the transform.position. Next up, we want to clamp the x and y values of the current position. And we do that just by simply doing current position.x is equal to the math f.clamp values, which is just a cutoff. And we want to clamp the current position.x in between the minimum x and the maximum x that we just calculated earlier. And now the current position.y is just going to be literally the same, the math f.clamp, and again the current position.y, and then the min y and the maximum y that we calculated earlier. And now we actually have to set the transform.position equal to the transform to the current position, I mean. Right here. And now we call this function after we move the player. So if the player gets out of the range of the screen, we then reposition him just right to the edge that he was at. So I just noticed that I had a min x and min x down here, so just rename the second one to the max x right here. So the min x is going to equal to the bottom corners and the max is the top corners right here. Sorry for that. So go back to Unity and let's start the game. So we still can move around with the player freely, but now if we go to the right, it's gonna stop at some point. Even if we want to move, we still can see the spaceship right here. The same is going to happen for the bottom, the left, and the right. So we cannot move out of the screen anymore. But it's still not as good as I would want it to be. Let's go to the scene and try to figure out why it does what it does. So the transform.position is this point right here, the pivot point of the game object, which is obviously working right here. If I start the game, then we have the spaceship on this corner with this point being the last point we display, which is not ideal, right? So we actually want the corner of the wing to be the object that we cannot move out of the screen. So let's just add a box collider to it right here and add a box collider to the star sparrow 1 and make it a trigger, so it doesn't really matter because it's just not going to be a collider. And in the script, we actually can get the sizes of this game object right now through the box collider. So go back to Visual Studio and the setup boundaries function. We also want to calculate the size of the game object and take that into consideration. So let's make a bounce right here and let's call this game object bounce and make that equal to the get component. And this is a collider right here, the collider that we just assigned to the game object dot bounce right here because it's a bounce object. Now we can get the size of the game object. So make a float, let's call this the object width, and set that equal to the game object bounce dot size dot x. Now for the object height, set that equal to the game object bounce again dot size, and this is going to be the dot y. So now we got the object width and height. So if I go to the game view in Unity and just drag the position out here, this is about where we stop. Right here is the pivot point, so let's just a little bit more. But we want to stop right here as the wing touches the end of the screen. So we have to do it by adding to the negative position right here. So to the min x, we want to add the size of this game object, and the other way around for this here, we want to subtract the size of the game object for the positive. Go back to Unity and let's do it. So the minimum x, we want to add the object width to the position right here, object width, and then subtract it from the maximum position so we don't go beyond. Now do the same for the minimum y, so just add the object height and then subtract the object height here. Now if we go to the game right here and start it, we already should have some decent boundaries. So if I go to the right, I can go past this point, this point, this point, and this point. So the top and bottom are quite good. I'm fine with that. But let's kind of downsize the rect transform of the game object. So go to the scene view and go to the star sparrow and then click the edit collider and just downsize the x quite a bit. Just go to something like 9 and go to the game view and just try it out. So if I hit the start button, we again recalculate the min and max y and x coordinates. Now if I go to the right, this looks good, this is also good, that's good, and that's good. And we can also, let's say, increase the speed. So just try it out right here. Go to like 20, and bam, bam. Okay, that's quite good. And we can go slowly, and if I increase the joystick, I can go faster. Now we already can fly around in here. But let's do one last thing before we pause it. So if I go to the right, I want the flyer to tilt. So let's rotate the z-axis. Right here, let's go to something like, let's say 25 looks good, like this. Okay, that's good. And I want to gradually tilt the spaceship. And now if I go to the left, I want to tilt it the same amount, just the -25 right there. Okay, that looks awesome. Let's try and do that in a script. So let's go to the player controller and let's make a new function. Let's call this the private void rotate player. Again, we want to rotate the player right after we move the player. So that we calculate the boundaries as the last point in every single update function. For this function, we need a new public float. Let's call this the public float and let's call this the max rotation right here. And let's set that equal to 25, just as we tried out before. So in here, we want to get the current x because the more we move the x value, the more we want to rotate the player. So let's make a float, a current x, and let's set that equal to the transform.position.x. Awesome. Now we want a float, let's call this the new rotation, and make a z after that, just a new float for the rotation. And now if the current x is less than 0, we want to rotate it negative, which means that the else statement is going to be the rotate positive. Now we want to lerp in between two values, which is going to be 0, and then the negative max rotation, because we are rotating to the negative. And we want to rotate in between these two values depending on the current position. So if the current position divided by minimum x, which is basically just the biggest number just with the opposite sign of the max x, and if the current x is equal to the maximum, this is going to be 1, which means that this value is going to be active. If the current x is 0, this is going to be 0 divided by anything, it's just going to be 0, so the rotation is going to be 0. And this means that we just rotate in between these two values depending on this coefficient, which is just a percentage basically. And now the new rotation right here is going to be equal to this number. Let's copy and paste this down here, because if we are positive, we want to rotate between 0 and the max rotation, and on the current x divided by the maximum x that we can achieve. And now just set up the rotation. Unity does not take vector 3 as a rotation, so just make a vector 3 and then convert it to a quaternion. So just make a current rotation, and this current rotation is going to be equal to a new vector 3, and we just want to rotate the z-axis, so just go to 0f, and for the z, we want to just put in the new rotation z right here. Now we want to make a quaternion out of this vector 3, just go to the quaternion, make a new rotation, let's call this new rotation, and just set that equal to the quaternion.Euler and just pass in the current rotation. And probably rename this to the current rotation vector 3, just to be clear what we are doing. And now just set up the transform.local rotation right here to the new rotation. And also made a mistake, it's called this new rotation right there. Awesome. Now we are calling this function right after we are moving the player, so that we can calculate the new rotation of the object, which is just the value that I figured out earlier, and then we calculate the boundaries so that we do not move out of the screen. That's a simple update function, and at the start we just get the boundaries. Awesome. Let's try it out in our game. So if I hit the start button and then move around to the right, we see that the player is tilting right there. That looks pretty awesome. Now we can freely move around the screen and not actually move out of the view of the camera. Awesome. Now we still want to set up the speed to something like the 20 that I tried out before. The max rotation, that's fine. And now let's start it again and just look at what it looks like. Now it's just a faster pace, and this is basically how our game is going to look like, just moving around the player with the screen and tilting, and we probably might even add a up and down tilt, but I don't know if I should do that. But this tilting to the side looks pretty awesome. So if you liked the video, which I bet you did, you should definitely comment down below and tell me what you liked the most. Subscribe to the channel and definitely like the video. And yeah, see you in the next one. Bye.